Hi again. In this video, I'm going to give you a brief overview of what wind is, what causes it, and how we measure it. You're going to need this background information as we start to explore wind in much greater depth in class. So you have all experienced wind. You've probably used wind to fly a kite. Maybe you've had trouble with an umbrella on a particularly windy day. Maybe you've been in a really bad storm, or maybe you've been in a hurricane. Maybe you've been in a place where there's been so much wind that the wind actually creates huge ocean waves. We're going to be exploring all of these things as we move further into our unit, but let's take a look at some very basic things about wind. So first of all, what is wind? Wind is one of those things, we all know what it is, but it's hard to define. So we have a picture here of a convection cell. So there is air moving sort of in a circular motion here. Not every arrow on here would be called wind. Because to be wind, the air has to be moving horizontally or parallel to the Earth's surface. Okay, those are the requirements for it to be called wind. So only two of these arrows would we actually call wind. And they would be this bottom red one here, because the air is going horizontally or parallel to the surface, and the arrow directly above it. When air is rising or sinking, we don't call it wind, we call it a current. So you would have currents on the sides where the air is rising and sinking. So what causes wind is the same thing that causes all weather. We know that weather occurs because the Earth is heated unevenly. Right at the equator, we know there are the most direct rays. So the equator is a very warm area, whereas the North Pole and the South Pole are significantly cooler. This uneven heating of the Earth creates differences in air pressure, and that's what causes wind. Right? We know that the equator is an area where it's very hot. So if it's very hot, we know there's low pressure. And we know that the poles are much colder. And if the air is cold, that's high pressure. So we have these different regions of high pressure and low pressure. And that's what causes wind. Wind always blows from areas of high pressure to areas of low pressure. If you were squeezing this balloon here, and you eventually squeezed it so hard that it popped, would the air go into the balloon or out of it? Right, it would go out of it because it's trying to get away from the high pressure to a place with lower pressure. So this is really important. We want to make sure we know that wind always blows from high pressure to low pressure. So on a weather map, we see lots of H's and L's, high to low. And so we can use these to figure out which way the wind is blowing. So wind would be moving from this high to the low, from this high to the low. Basically, the wind is going away from the high in all directions, and it's going to the low from all directions. If we look over here, the wind is going to leave the high and go to the low. Leave the high, go to the low. Now, the speed of the wind is going to depend on the air pressure gradient. Do you remember when we studied topographic maps, we were looking at gradients, how steep the land is? It works the same way with air pressure. We use the gradient formula to calculate basically the difference in air pressure over a certain distance. The steeper the gradient is, the faster the wind will blow. Pretend that this was the topographic map, and you were where this H is. If you were going to ride your bike, would it be easier to go sort of toward the northwest or to the southeast? Well, the northwest, the lines are farther apart. There's a lower gradient. So this area here, the wind would be slower because there's a lower gradient. In this bottom right-hand corner, or the southeast area, the wind would be the fastest because there's the steepest gradient. The isobars are closest to each other. So let's look at a sample problem like that. So this was a question from a Regents exam a few years ago. The question asked, would the wind be blowing faster from A to B or between C and D? Okay, so we need to look at the gradient. So we'll notice that point A has a pressure of 992 millibars and B is 1008 millibars. And they're spread apart over a certain distance. Point C and point D are spread the same distance. Point C has a pressure of 992 millibars, just like point A did. But unlike point B, the pressure at D is only 1,000 millibars. So which one has a steeper pressure gradient? Right, from A to B. Because over here we have a difference of 16 millibars spread out over that distance. Whereas down here, we have a difference of 8 millibars spread out over the same distance. Okay, so let's talk a little bit about how we measure wind. When we measure wind, there are two things we want to be able to measure. We want to be able to measure the direction of the wind and the speed of the wind. To measure the wind direction, we use a tool that you've probably heard of. It's called either a wind vane or a weather vane. And they come in all different designs, and you can basically get very plain ones, you can get fancy ones, things, if you're into witches, you can get a witch one, or a dragon, whatever, soccer, whatever you like. Basically what will happen is when the wind blows, it's going to hit this. Because the back of the arrow has a broader surface, has more surface area, the wind will blow against that and push that back. And that will make the tip of the arrow spin around and point to where the wind was coming from. Okay, so those are weather vanes or wind vanes. To measure the speed of the wind, we use an instrument called an anemometer, which will measure the wind speed either in miles per hour or in knots. And in class tomorrow, we'll take a look at an anemometer and I'll show you how it works. But for now, just write down that an anemometer is how we measure the wind speed in miles per hour or in knots. Now, the last piece that I want to briefly talk about is how winds are named, because we're going to be giving names to the wind. The key with this is that winds are always named for the direction they come from. It's all about where the wind is coming from. So let's say this yellow arrow represents wind. It's coming from the north. It's blowing towards the south. Because it's coming from the north, we would call it a north wind or a northerly wind. As opposed to the red arrow, which is blowing towards the north, but it's coming from the south. So that would be a south wind or a southerly wind. Let's take a look at a couple others. So in this picture, you have this woman on the beach, and the wind is blowing her towel or whatever that thing is blowing it behind her. So if we look at our compass down here, it's blowing this object towards the west, but it's coming from the east. So that would be called an east or an easterly wind. In this picture, the wind is blowing out of the cloud. It's coming towards the southwest, but we name it based on where it's coming from. So this would be a northeasterly wind. It's coming from the northeast, and it's blowing towards the southwest. Now, this last one here, the little pieces of pollen and the seeds from the dandelion are being blown towards the northeast, so the wind must be coming from the southwest. So tomorrow we'll quickly review all this, and we're going to explore wind in much greater detail. Thanks for watching.